Alright, in this video lesson I'm going to talk about the basics of the JK flip-flop and transition table so that we can talk about the design of synchronous counters. First off, I'm going to make an assumption, lay out real quick that you guys are already familiar with the truth table of the JK flip-flop, basically meaning all the states of J and K, all the operation modes of the JK. So for the input states J and K, we have 0, 0, 0, 1, 1, 0, 1, 1. And on the output types, JK, 0, 0 are no change. 0, 1 state, reset. 1, 0 state, set. 1, 1 state is going to be toggle. Alright, now moving into the transition table. Of course, this is basically operation states for Q. Basically, JK is 0. There's no change on the Q output. 0, 1 for reset, 1, 0 for set. Don't use these too often, but toggle mode do use quite often in the design of counters. However, since this is non-sequential counters that we're going to be talking about, we will appreciate reset and set in this case, and that's going to come into play when we talk about the transition table. Using the bigger board here, I'm going to fit as much as I can onto it. Whatever doesn't fit, we will erase and put more on here. So, all right, the transition table is important because what the transition table is going to do is it is going to tell us at what points 0 on the Q output will change to a 1 after the clock pulse, at what point a 0 will stay a 0 after the clock pulse, at what point a 1 will become a 0, and at what point a 1 will stay a 1. So we're going to look at the truth table, or sorry, the transition table, and appreciate all those conditions. So I'm going to do a table that's going to look similar to this with a couple of exceptions. I'm going to do a Q, a J, a K, and the Q plus 1. Alright, JKQ, and then I have Q plus 1. Okay, great. What is all that? Okay, JK is just JK. It's going to be the states of J and K. This Q is going to represent what Q will be prior to the clock pulse. We're going to have a JK. We're going to have what Q is before the clock pulse. We're going to have what Q will be after the clock pulse. So what am I going to do? I'm going to set up all the possible combinations for JK and Q before the clock. So I'm just going to run through and count in binary through all the sequences. Alright, so all the possible combinations for J and K, all the possible combinations for actually JK and Q before the pulse. We're going to figure out what's going to happen to Q after the pulse based on these combinations. Okay, so JK, if JK is 0, then that means that the flip-flop's in a no change state. So if Q was 0 before the pulse, that means it's going to be 0 after the pulse. So Q plus 1 is going to be 0. Okay, QJK, J is 0, K is 1. Alright, that's a reset mode. I have a little mnemonic. If you watch my S&R latch video, holds true here. You can set a 1 or reset a 0. So set a 1, reset a 0. So if I have 0, 1, 0, 1, I'm in the reset state and Q is a 0 on that next clock pulse. What happens to Q plus 1? It's still a 0 after the pulse. Okay, J is 1, K is 0. Alright, J is 1, K is 0, that's set mode. So if Q is 0, it will become a 1 because the JK flip-flop is in the set operation mode. So it becomes a 1. Alright, Q is 0, J is 1, K is 1. What state is the JK flip-flop in? It is in toggle mode. Therefore, it was a 0, it will become a 1. Okay? And we just continue that all the way through. I'll do one more and then I'm just going to fill in the rest. J is 0, K is 0. It's in a no change state. Q was 1. It will stay a 1. Okay? This is reset mode. It was a 1, it'll become a 0. This is set mode. It was a 1, it stays a 1. This is toggle mode. Toggle means Whatever it was before the clock, it will alternate after the clock. So if it was a 1, it has become a 0. Alright, so this is a transition table. We've looked at every possible combination for J, K, and Q and figured out what the output would be after the clock pulse for all the various operation states of J, K. So we built this table so that we could come up with 4 statements. I'm going to grab some other colors. Be right back. Alright, statement number 1. And if I don't get lazy with the video, maybe I'll go and edit in the statements after this. I'm just going to say them right here. Alright, statement number 1. If J, as long as J is 0 and Q is 0, Q will not toggle. It will stay a 0 regardless of what K is. So see whether K is 0 or whether K is 1. It was 0 before the clock. It was 0 after the clock. There's no change. Alright. Next statement. Right here. Statement number 2. And I'll number them for you. 1, 2. Statement number 2. Alright. As long as J is 1 and Q is 0, Q will be a 1 after the pulse. It doesn't matter what K is. It can be a 0 or a 1. That's shown right here on these 2 truths. Alright, statement number 3, use green for this. I have to steal from a couple places. Let's take it from here and from here. And statement number 3 I'm going to say is as long as K is 0 and Q is 1, Q after the pulse will stay a 1. It will not change. So K is 0, Q is 1 before the pulse, it's a 1 after the pulse. So that's true with those two statements. Okay? And then last statement we can make off this, go back to black, statement number 4. From those 2 truths, if K is 1 and Q is 1, Q after the pulse will toggle to 0. K is 1, Q is 1, therefore it will toggle to a 0, and it doesn't matter what state J is in.